let's think about speed first. I'm thinking about average speed. That means over a whole journey. Okay, so that means from 0 to 14. How do you work out speed? It's distance on time, right? We'll see if it picks up. Just go for it, man. It's okay. All right, now look at the graph. Actually, you might not even want to think about the graph. What did the Mandarin do? Okay. No Iron Man puns, please. Okay. How far did it go? What was its total distance traveled? I should put that because it's different to displacement. Well, it went up 3, then it came down 3. Right? So that's 3 plus 3. Okay. Now, by the way, take notice. Even though the first time it went up, and then the second time it went down, so directions are opposite, when you're thinking about distance, it doesn't matter. They're both positive, because distances always have to be positive. Okay? And then you divide by your time unit. So that's 3 or so. Okay? I suppose that would be meters per... Yeah, that's right. I'm just going to say time units. I'm going to stop talking about this silly time unit that I was... Okay. Yeah, I don't know, maybe. Who knows? Okay, now, that was average speed. Which doesn't make sense, okay. Now, average velocity. Remember, velocity is in terms of displacement. Okay? So what was the total displacement? From 0 to 14, well, it started at my hand and it ended at my hand, right? So therefore, its total displacement was zip. It came back to exactly where it was coming from, right? So it's 0 on 14, sorry. Which is 0. Okay, is this making sense? Yeah? Okay, now, I just wanted to go through one worked example of how these concepts fit together before I set you on some very, very simple exercises. Before we get to any of the differentiating or anything like that, okay? You just want to be able to remember what these mean and be able to interpret them off a graph. Okay, that's the first key skill that we're going to get before we differentiate or integrate. Integrating is where the real fun is. Okay. So let me give these out.